This meeting is being recorded.
Hello. Good afternoon, sir.
Good afternoon, Rashid. So today Rashid is going to present about ArcGIS and qGIS using some tutorials and various applications to it. So I think we should start now. Are you ready, Rashid?
Yes, sir. I'll share my screen. Okay, is my screen visible?
Yes.
Okay. So, good afternoon, everyone. Today, I'm going to present basics about ArcGIS and QGIS, covering some basic tutorials, and I will also help you understand some of the basics of GIS and how to work through any general GIS software with covering some basic tutorials. So, moving on. So we have already some basic insights like what is a GIS, what is GIS? GIS basically is geographical information system. But what does it mean? Like it basically is a system that is basically created to manage, analyze, and to hold database and to interact with data and to understand the pattern in data so we can get something out of it. So geographical information system is just basically a tool which helps us to perform many analysis and understand the pattern of data. It can also be understood as a science of part of data science. So one of the some of the basic applications and of the GIS is basically to data management and data collection. We can display data, we can understand pattern in data, we can plot data, we can map data, we can use maps, we can use remote sensing or remotely sense data and satellite imagery, combine those imagery. We can also use 3D GIS. So in this tutorial session, basically I will be focusing on spatial data and mapping. So there are a lot of applications that can be done, and there are a whole lot of things that can be done through JS. So that cannot be covered in a single session. But I will be like basically focusing more on giving you some basic insights about GIS software. That's basically qGIS, that is the open source software, and ArcGIS, that is the licensed software. And then finally, we'll be creating some maps and interpolating and georeferencing some of the files. Moving on, before moving on to GIS, I would like to give a brief overview about some of the GIS file formats. Like we have some basic file format that we need to understand. Like in GIS, we basically work through a shapefile format. That is basically a vector data format developed by ISRI. So that we will be working mostly through shapefile format, but with this shapefile format comes a number of formats that goes through with it. Like we have .shp, .shx, .cbg, .dbj. So we will look after them, but we need to see that this shapefile format is the most important format while dealing with GIS data. Like we have a lot of other formats also, but this is the most common one. We also have geotiff format that we usually use when we are georeferencing our data, and while using and displaying data and working on GIS software, we usually refer to each file format using a layer file. We also have XML and GeoJSON format that are also used, but most commonly we use shapefile format. Moving on, so about this tutorial workflow, I will first start with giving you some basic insights about layers, shapefile, how to work around layers, how to edit layers, how to open data, how to display Excel sheets and data. Then after that, I will also go with like adding data to ArcGIS and QGIS, working with data, understanding data, how to display your data. Then moving on, we will have some tutorials on georeferencing, how to georeference some of the maps over the real world coordinates. Then we will learn how to develop a digital elevation model of any region. Then like we have like, a lot of work related to interpolation in our studies. Like when we go for research work, we calculate values and we need to go for spatial interpolation to better understand the pattern and to interpret our results. So I will give a brief tutorial about creating interpolation through ArcGIS, and then after, in the end, we will also learn how to create a map through ArcGIS and export it. So moving on, firstly, we will be understanding basics about layers and shape files. So first, let me go through QGIS. Like I understand, like most of the people here joined here have QGIS installed. Any version of QGIS would do. Like I have 3.16. This is little bit older version, but the newer versions are also similar, but they have some added features. So you can see the basic workflow of qGIS is like we have a browser here on the left side. On the top, we have different panes. So when we are working on a new project, we can just select a new project. So firstly, we need to open any shapefile or any layer or add any layer. So to add any layer, we can go to layer option, and then we have add layer options. So through add layer option, we have different options like add vector layer, add raster layer, add delimited text layer, and lot more. So firstly, we are going to open a vector layer. I'm going to open a Dhanbad shapefile. So we can select the location of our layer from here. So I've already provided you a zip file where I have given the different shape files. So you can see here, these are two Excel files. This is Dhanbad city shape files, and we have this a number of files named Dhanbad district. So here, these are all shape file related to Dhanbad district, but we need to open only .shp file. The other files are just extension to it, but we need to have all these files together in order to open the Dhanbad shp file. So once I select it, I will add this file. So you can see the Dhanbad shapefile is added here. This is basically a Dhanbad vector-based shapefile bordering district. So we can see that we can see various properties of this shapefile by going to right-clicking on this layer. We can switch on or off this layer. And one thing we can also do that we can add a background layer of by going to XYZ tiles. We can open the whole world street map. So you can see that I have added a world map layer here. So we can see that we can't see the Dhanbad district layer now because it has gone beneath it. So we can select this layer by right clicking it, and we can what we can do is we can select move to top. So it will move to top of this on this world street map. So now clicking on it, right clicking on it, we can get various options. So we can go to properties and see various properties of these layers. Like we can get information about these layers. We can get the encoding geometry. We can also get the projection type for this layer and the extent of this layer, like latitude, longitude, extent. And we can edit the layer that we have seen that we can edit the features of this layer. And uh, we can change the color. We can even we can make it hollow, and we can edit different features. So this is single layer. Okay. And another thing, if we need to edit a layer, we have a pencil option here. This just switches on the editing option for this layer. So we can edit and draw anything on this layer. For example, if we need to create location of some stations or we need to create some extra points, we want to create a sketch layer. That is, for example, we don't have any initial layer. So if we want to create a sketch layer, we can just go into this option where we can create another layer. For example, if I want to create any layer, and then we need to select what type of layer geometry it is. For example, if you want to create a point layer or a polygon. For example, I want to create a point layer. We can select point. We can see we have a scratch layer here. This small marker tells that this is a temporary layer. So as we will, whenever we will close our GIS software, so this layer will be deleted. So if we want to save that layer, we need to save it, make permanent. So now we have selected this layer. Now we can draw anything based on, as we have selected initially, there is a point based layer. So we can go for points and we can draw points over the geometry anywhere. And we can edit those points, geometry, and color and everything by going to this button where we can do layer styling. So we have three layers open right now. If I close this layer, this is the point layer. This is the Dhanbad district shapefile, and this is our open street map that is open in the background. Okay. Now this is about opening and editing any vector-based layer. So if we want to open a point or points or anything which we have in an Excel or CSV file, so how do we do that? We will again go to layer, add layer, and for example, if we have a Excel or CSV file in which we have data points that we need to plot, so we can go to add delimited text layer. That text layer should be in CSV format. So I have already some points in this. This is some data points. We can just add it. So we can see that I have three fields in this layer. The second and third field are actually the latitude, longitude, and latitude of this in the file, and the first field is the magnitude of the earthquakes. So I will just select the X field is the latitude and Y field is the longitude, and I've already selected the CSV file. Then we will just add the layer. So we can see we have got the points. that was in the CSV file plotted in our workspace. So this is this is how we can plot the data from any CSV file on our map, and we can edit it all. We do all the styling and everything. And we can, another important feature is that we have an attribute table which shows all the data points. When we right click on this layer, we will get an open attribute table option. So here we can get all the information related to our layer. Like these are all the points that have been plotted. The second and third column are the latitude, longitude coordinate, while the first column is the magnitude. So we can play around with the data. We can even delete the field and edit the fields using the options. So we have 3 fields right now. This is how we open and edit and close the layers in QGIS. Now I would like to move to ArcGIS and show the same thing. Like I have already opened the ArcGIS. This is the basic ArcGIS workspace. Similar to QGIS, we have different panes here, and this is one of the important pane, like table of content. This table of content shows what layers are open. Like similar to QGIS, like we have different layers showing like this layers are open. Similar to that only, we have similar thing in QGIS also, ArcGIS also, which shows different layers. If we need to add any layer or any shapefile, we need to go to this add data option. In this add data option, it will mimic your desktop, and you can just go to the folder. Like I will go to this GIS tutorial folder, and I will try to open the same Dhanbad shapefile layer. So you can see here that the Dhanbad district.shp file is there. So I will just add this layer. So yeah, it's added. So you can see this layer is here. Similar to QGIS, you can add any background map also. Like you can go to add base map, and you will get different options to add topography map. You can add imagery. I'm not going to do that because usually adding satellite imagery takes some time. So you can add it through here. So we have one shapefile open here. By right clicking on it, you can see you can remove this shapefile by going to remove. You can see its attribute table. Uh, you can save it as a layer file, and we have also edit features option. Like if we want to edit something on this layer, we need to go to edit features and start editing. Now it will get editable. You can edit this layer now. Okay, and moving on. Okay, I will like also show how to add elements to the layer. Now it's like editor is here, so you can start editing. You can make polygons and other features on the layer. And for stopping the edit, you can just go to the editor and just click save edits. So we can save the edits. So this is how we open a vector file. For like similar to QGIS, we can also open a similar to QGIS, we can also open a CSV file. As we can see that going to add data, then we can see that the CSV files are visible. So just we can click on them, and it is here. So we have like single two layers now. Like we have a Dhanbad district file here, and other file is this CSV file. So to display the CSV file, we will just go right click on it and go to display XY data. So it will ask about the field, similar to in QGIS. So we will say that like field 2 is the our longitude, and field 3 is the latitude. Okay, I think it has. Yeah, then we can go to the layer. This is added the layers of the events. Then we can go to the layer and click on zoom to the layer. So we can see that it has added all the points that were in the CSV file. We can similar to QGIS. We also have an attribute table in ArcGIS. Actually, the QGIS and ArcGIS workspace is little different, but all the concept and working is all same. So we can see this is the table which shows different points, our data points. This is the longitude, latitude, and the magnitude. And this shape is pointing that all are drawn through points. Okay. So like we have already now we know like we how to add the different vector and CSV like database layers and how to start editing. Now moving on, I've shown like how to open vector raster files, adding CSV data, and like how to view the attribute tables. And attribute tables, we have different fields and attributes. Now I will start off with the first tutorial, that is the georeferencing. In georeferencing, what we are going to do is we have a plan or sheet that we need to add upon the real world coordinates. For example, in this tutorial, I'm going to show how to georeference a CSAT sheet onto the real world coordinates. So we are going to do georeferencing through qGIS. Similarly, we can also work that in ArcGIS also, but it is very easy to do in qGIS. So I usually prefer qGIS. And so, like what we do, that we first open the this our sheet in the georeferencing pane box. Let me show you before going to the options. Let me show you how we do it. So you can see that we have vector options here. Different analysis can be carried out through these options. Like we have geoprocessing tools, geometry tools, analysis tools, research tools. Similarly, in raster we have different analysis tools. So in raster we have georeferencing tool. We just open that tool. After opening this tool, we need to add our file that we need to georeference. So in this case, I have a CSAT sheet number 12 that we need to georeference. I will just add that. So this is the sheet. So we can see we have, but before georeferencing, we should know that the sheet that we are georeferencing should have coordinates written at its corner, should have some ground control point, because we are going to take 2 or 3 ground control points, add them to it, then only it will georeference that this sheet onto the real world coordinates. So we are going to use 3 GCP points that are ground control points. So first corner is this one. So we are just going to click on it and add the coordinates. So it is 84 east and 25 north. And this one is 87 east and 25 north. And this is 87 east and 29 north. And this is 84 and 30. Okay. So now I have added 4 ground control points in the corners of the coordinates through which it will be georeferenced. So we will go to this play button. So it prompts us to add a transformation type. So we usually use the polynomial transformation type and nearest neighbor resampling method. And this will output a TIFF file. So we will just select the location of this file. Okay, it will just give us a TIFF file here. And then we'll go OK. And then we'll again click the play button. So now it has georeferenced our sheet. So now we have got a georeference sheet. Now, if you want to open it, it is in the raster format. So as we open all the layers, we go to layer, add raster layer. Then we select the location. This is our, yeah. Yes, you can see that I have added our georeferenced sheet over the real world coordinates. So this is the location of our sheet. So now what we can do is we can use this georeference sheet to trace out all the features that we need. For example, for analysis, maybe like in this sheet we have different geological discontinuities. So we can trace out different geological discontinuities and then use it for our analysis, maybe to calculate rupture length, to see that how which earthquakes are close in proximity to different faults. So I will also show a brief tutorial to how to trace the faults. Like now we have this sheet here. So what we can do is, for example, if we need to trace a fault, so we will create a temporary scratch layer. Maybe we will name it fault. And then we will select a geometry type. So this time it will be line strain because we are tracing linear elements. Okay. So we have got a temporary scratch layer. Okay. We will open the editing window here. So now we can see that editing is started. So we can edit the feature, this layer, this temporary fault layer. We will click on the line symbol. Now we can trace any of the faults. For example, if you want to trace this fault, so we can just click on it and we can start tracing it. We can see that I have traced this single fault. If I close this layer, so I think you can see this is the fault that I have traced. And if we go to this, what we can also do that we can create different fields before tracing. I have not done that. I think we should do that. We can go to attribute table and we can add different fields before tracing. Like before tracing, it will prompt us to enter the number of the fault or name of the fault and or length of the fault or any metadata related to that fault. So we can know that what are the faults we are tracing. So to add any new field, we can just click on new field option here. So like I will add the name of the fault. I will also add a field as number of the fault. Okay. So I've added two fields here and we can save. Okay. So I will again start tracing. We can again click on this layer, then start editing, then select this line tool, and we can again start tracing. So I'm tracing this fault. So once I have complete tracing, I will just right click. So it will prompt me to enter the fields that I have already created. There's a name of the fault. For example, if I am entering like West Patna fault, okay, and number, for example, I have written 1. Okay. So now I will get these details in the attribute table. So I can do similar things with all the faults and I can keep on getting details of all the faults that I have plotted. This can be used afterwards. Then we can use these details to calculate the area and length of the faults. And we can also see how many earthquakes are near to that fault. Okay. So this is georeferencing basically. Now moving on, the this is basically the workflow of georeferencing that I have already discussed, that we go to georeferencing tool and open our it can be JPG or PDF file, but we need to have the coordinates. Then we select the ground control points, control points. The ground control points can be, we can also go with a single ground control point, but it should be entered through coordinates. So select the transformation type and then we get the TIFF file and we open that TIFF file through raster because the TIFF file is a raster format. So we add that layer through raster and then we get the
Uh,
our file over
Rashid,
the, yes, yes, sir.
Rashid, can I georeference the geological polygon that is present here? By using this
Uh,
method, can we apply georeferencing to this geological map or small geological patches that is seen here?
yes. Yes, yes, you can georeference pretty much anything, but we need to have ground control points to actually overlay that information over the real world coordinates.
Okay, no, I'm talking about this map only. This map we have a ground control
Okay.
point, and so we
Hmm.
have a small patches of
Oh,
geology
geology.
present there
Oh,
in
yeah, yeah.
red and
Yes.
others. So we can take all those regions also.
Yeah, you can do that through Polygon. Let me show you. Like if
Okay.
we can create another, let's show it. I will create another sketch layer that we will call it like geology, and we will select the geometry type as polygon. Okay, so we have got a new sketch layer that is called geology. So we will, the editing is on. So we'll select the polygon option. Now any polygon that you need to, for example, if you want to trace out this geological patch here, so we'll just trace out this patch normally as we do in like while we trace line. But we need to do it manually actually because this is a JPG and PDF figure. So we need to, so like we have traced out this patch. So if we close out this, so we have got this patch. Similarly, you can trace out other geological portions to polygon, or if they are linear features, then we can use line functions. Is that you are asking?
Yeah, yeah, same, same.
Okay. Another important thing is that these two scratchlet that we have created, these are now like they are temporary. So we need to save them because if I will close QGIS, these layers are already there, but these will like vanish off because they are temporary. So what, because we can see this catch option here. So what we need to do is to save these layers. We will just right click on them. We'll go to export and save features as. Now we can save them as in any format, like we can save in lot of formats are there, but we usually use shapefile format. So I will like save in them shapefile format. So we can like just add shapefile, and once I save it, this stats feature that was showing here is gone. So now this layer is permanent. So it will not vanish off once we close qGIS. And we can then just remove this layer. Okay, now we have discussed georeferencing and opening and like removing and editing on various different files. Now I'll move on to DEM. So like usually in lot of our work, we need to display or work with the elevation model or make elevation model or display elevation data. It is sometimes pretty difficult in different softwares, but it is pretty easy to work on and create an elevation model in like in GIS using qGIS or ArcGIS. So I will show how to make a digital elevation model for pretty much any region using ArcGIS. So like first for any elevation model of any region, we need to have that elevation data. There are a lot of websites and online resources available. So I have mentioned one online resource in my presentation that you can go to. This is one of the resources maintained by UCSD, University of California, San Diego. So there you can download ASCII file of elevation data as well as we can get free air gravity data also. We will save that data in the CSV file, then open that CSV file in QGIS or ArcGIS, and then save that as a shapefile. And then we can also remove unnecessary points from the file and then open that in the ArcGIS and then carry out interpolation to get a DEM. So like I will show how it's done. I've already opened this website here. Yeah, this is it. So this is the website that for that the link is given. So we can go to this first option, get ASCII XYZ topography. Here we can enter the extents of our data, like for how much region we want data, we can enter latitude and longitude, and we can get the topography data in the Excel format. I've already downloaded data for Dhanbad region. You can see this is the DEM data. This is the longitude, latitude, and this is the elevation in meters from MSL. So now we are going to use this data to get our DEM. So what are we going to do is like we are going to open QGIS. I'm going to close all these layers and I'm going to zoom to this Dhanbad district layer. Okay, I will remove this layer and again add this layer. Again, I will add this vector layer. Okay, it's already here. So now what I'm going to do is I'm going to display all those elevation points in this. So we have already known that how we display the CSV data. We go to add delimited text layer. Then we need to select the file. So this elevation Dhanbad file. So here in the first field we have latitude, longitude. So we'll select the longitude. The second field we have the latitude, and third field is the elevation. So we'll add the points. So we can see that we have all the points on which we have the elevation data. So what I will do is now I will save this file, the elevation Dhanbad file in as a shape file. So to export as a shape file, we will just right click on these points, go to export, save feature as, and then we can save it anywhere. I will save it here. Elevation. Okay. So we can see we have got this elevation files here. These are the shape files associated with the file that I have just saved. So what I have done is I have opened the CSV file and converted that CSV file and saved it as a shape file. Now what I will do is I am going to carry out the analysis on this qGIS ArcGIS software. So I will close this file. Now I will open those elevation data points that I have saved. This is elevation.shp that I have recently saved. So these are all the points. And I will open the that shape file, Dhanbad district. Okay, this is the shape file. Okay, I have accidentally drawn this circle. We can remove this circle by editing. We can like start editing, and we can. Okay. Okay, the circle is gone. Okay, it's still there. Okay, let it be. So, what are we going to do is we are going to use Kirgin interpolation, that is a spatial interpolation based technique to interpolate through all these points. Okay, let me open it again. Okay, so in ArcGIS we have all the various analysis options available in this Arc toolbox. This Arc toolbox is small red box shown here. So we have a whole lot of options that you can explore. It moves on from 3D tools to data conversion tools, and we have geostatistical analyst tools. And mostly we use this spatial analyst tool by going for interpolation. And also in this spatial analyst tool, you will find an option as interpolation. In this interpolation, there are a whole lot of different types of interpolation and trend available. You can use a spline. You can identify pattern in data using trend. You can use natural labor. So usually for spatial interpolation, we usually go for Kirgin interpolation. So we will open this Kirgin interpolation toolbox. In this Kirgin interpolation toolbox, it asks for various inputs. Like first is the input point feature. What are the point features that it's going to interpolate using? So our point feature layer is our elevation layer. This is the point feature layer, and this is the Dhanbad shapefile. So you have to just select the elevation layer. Okay. Now in the second option we have Z field, like which field you want to interpolate using. So in this we have three fields like longitude, latitude. This is the elevation. So we are going to interpolate based on elevation. So we'll select this third field. Now we have this output just with raster layer. We will use the ordinary changing method. Then we need to go to the environments, and then we need to set the base environments for interpolation. Like first one is the output coordinates. So our output coordinates will be inside our Dhanbad district layer. So we will select same as layer Dhanbad district. Then we need to select the processing extent. What will be the processing extent of the interpolation? How much far it need to carry out the interpolation? So that will also be our same as the Dhanbad district boundary layer. So it sets the output coordinates. Then after that, lastly we need to go on to raster analysis and just select the mask layer. Like which layer we need to mask, which the interpolation data will mask on which layer. So we'll just select the Dhanbad district layer. Am I audible? I think my internet connection is unstable.
Yeah, you're
Okay. So sometimes it takes some time. Yeah. So the analysis is complete. You can see it is displaying the interpreted result here. To view the interpreted map, as we have masked our Dhanbad district here, so we need to turn that off. So now we can see the data elevation model, and this is the when this is our interpolation layer. If we switch that off, it will go off. So now we can see various properties of this layer. Going to the just double click on it, then we can see various properties. And when we go to symbology, then we can set different symbologies and we can set the classes. Like currently we have 9 classes. The data is divided into 9 classes, like setting from different colors. We can also go on and select different interpolation scheme based on color. Like if we can change the scheme. We can also change the number of classes. We can increase or decrease the number of classes. So now we have only 5 classes. Okay. So like this is our final model, elevation model. We can see the various values also. And in currently, like in ArcGIS, we have 2 data frames. Like this is the first data frame. This is our analysis data view. If we want to go on to make a map out of this and then export a map, then we need to go to the layout view. So this is the layout view. In this layout view, we can do everything and prepare map and like prepare a map, beautify it, add features, legends, everything, and then make it exportable. And we can export it through a package file or to JPG, BMP, or PNG, any format. So this is basically how to make a data elevation model, how to download data, upload the data, convert it into a shapefile, then carry out the interpolation and create a elevation model. Second thing that was basically more important is the carry out a spatial interpolation that has already been covered in the DEA model, but still I want to briefly go through it. Like to carry out any spatial interpolation, we usually go for kriging interpolation. So like we need to add region and grid shapefile. So in this we already showed that we added 2 things. First was our region shapefile, that was Dhanbad district. Second was our elevation data points. That was the grid points in which we had our values. Like we can open the attribute table. So we had all the values. After that, we need to set the field to interpolate on. Like we need to interpolate using the our elevation data points, then set environment and processing extent, and finally get the interpolation result. Now I will like to show how to prepare a full map that can be exported and used. So I will close this elevation layer and all these layers. Now I will open the another layer that I've already provided in the zip file. That is, when you will go to ArcGIS, you will see the Kishanganj shapefile. I'm going to open this shapefile. So this is the Kishanganj district shapefile, and similar to qGIS, we can also like make it hollow and change the color and all. If I want to make it hollow, we can go to symbology to edit the symbology of the layer. We can increase the thickness of the boundary and all. This is the Kishanganj shapefile. Now moving on, I have this is the grid points. Grid shapefile.ssp. This is the shapefile which contain all the grid points. So these are all the grid points of on the Kishanganj shapefile. If I open the attribute table of this grid point, I will get various points. Yes, please go ahead. Okay, this is the attribute table. In this attribute table, we can see we have latitude, longitude of each grid point. We have the attribute through which we are going to interpolate on, that is PG at 2% and 10% probability of accidents. So we are going to interpolate using one of these to create an interpolation map, and then finally create a map that can be exported. So I will similarly, like I explained last time, I will open the Arc toolbox, then go to the Spatial Analyst tool, go to KV interpolation. I will select the shapefile that we are going to interpolate using these grid points. So I will select this grid shapefile, and then we will select that Z point, that is the PGA. So in the Z field, that we will select the PGA values that we are going to interpolate using, and we are using ordinary keying method. Then we will go to environments, and similar to last time, we will just select the output coordinate system as our Kishanganj layer. And we will select the processing accent also as our Kishanganj layer. Then in raster analysis, we will also select the Kishanganj layer. So it will mask the Kishanganj layer when the result will come out. We'll just run the analysis. Okay. So the KGIS analysis is in progress here. Okay, so the result is here. We can see the interpolated layer is a new layer is there. This is the interpolation layer. So we can see it is showing different fields, and we are getting the interpolation map here. If you open this layer, we can see we have a total of 9 classes, field classes. We can change that. We can make it to 5, and we can also change the coloring scheme. Okay. Now, if we want to create a map, what we need to do is that this is the data view, this is the processing view. We need to switch to the layout view. In the bottom of panel, you can see we have two view points. Like first is the data view and second is the layout view. When we switch to the layout view, we have a template for the map. So we can change this template going to this button. This is change layout. So we can select any suitable template for our map. So if like I'm going for a landscape template. Okay. So this is the template. We can increase the thickness of our layer. We can switch our grid points off, or if we are going to switch them on, we can increase the size. We can even change the shape of our grid points. Okay. So this is our map. We can adjust it to fit in the layout layer. Yeah, it is fine. Now we need to add coordinates, latitude and longitude to this data frame. Like this is the Kishanganj district, so we need to have latitude and longitude. So we will just right click on this frame. We'll go to properties. Here we can see there is an option called grids. So we'll just click on grids and select new grid. Now here we can draw any type of grid with any type of spacing. So we'll just go with gratitude. We can select like if we want tick marks or not. So I'll just go with labels only. And like you can see like we have got some points, but the size of the points is very small, so we can't see here. So we'll again go to the properties. We have got this gratitude here, so we will just edit the properties of this gratitude. So we have got our grid at 10-minute spacing. That is fine. We will just increase the size of the labels. So we'll go to labels, and just we will increase the maybe make it 15, and we will turn off the right label and the top label. We can make the left label vertical. Okay, so maybe like it's a little big. We can make it more bigger. We can see the latitude and longitude. So on the what else we need to add? We need to add the legend, so we can see all these various parameters that we have done. So we can write PGA here. So like we have three layers right now. First is the grid shapefile, that is the point shapefile, vector based. Second is the Kishanganj, this shapefile. This is the boundary of the Kishanganj district. Third is our interpolation result. So what we will do is we will go to insert here. Insert, we will go to legend. In legend, we can select which of the points or the layer we need to show on legend. Before that, we need to change the file name of the legend. So to change the name of the shapefile, we just double click on it, go to general, and then we can just write grid points for this one. This is the Kishanganj district, so we can write Kishanganj. This third one is basically the PJ we have already written. Okay. Now we'll go to insert legend. Okay, we have got all three. We click on next. We can select a border for the legend and then we can finish. Okay, we have got 2 times the PJ. We'll double click on this legend. Once we double click on this legend, we will get the legend properties. So here we can see we have a grid point Kishanganj. We have items. We can change the writing style, or we can change the size of the letters and all. Okay, now we have got single. So this is basically the legend. What else we need to add? We can add many things, like we can add a picture of the Indian map pointing towards the Kishanganj district. We can add the scale bar for our map. So this is in miles. So if you double click on it, we can set it to kilometers. So this is how we can create. We can do a lot more things. You can explore using going to insert. You can see you can add text. You can add text. We can like add maybe add title to this map. You can double click on it and add anything. Like you can add text here. Okay. Increase the size of the text. So once you have finally created a map, so we need to export the map. So you can go to file. Just go to in the file you will get an export option. In this export option, you can just select the location where you want to export. You can increase the resolution also, like 150 dpi, 75 dpi. You can select the different formats. Like I'm going to export it in JPG. You can click on save. So I think the map is exported. Yeah, we have. This is the map that we have got. So you can do a lot more things. Like pretty easy to carry out interpolation, make maps using ArcGIS and qGIS. Like this is the basic tutorial that I wanted to carry out. And before in the end, I also want to discuss, like there are a lot of things that can be discussed in qGIS and ArcGIS. So there are a lot of resources that can be gone through. Like I've already shared this PPT. You can go through these links. You can download data by country. Like for any analysis, we need to have shape files of different regions, different country. So you can use these links to get the shapefile and data. You can also download shapefile for cities and districts all over the world. You can also use that geometric data dissemination tool, Bhuvan. This is maintained by Geographical Society of India. So you can get a lot of satellite data and the elevation model and other data from this website. You can also use Bhukosh, and this is this is a website maintained by UCSD. So we can download whole lot of elevation and gravity data from here for any region in the world. And we, while using like any software, any tool, we have a lot of queries and problems. So you can always go to this GIS Stack Exchange. So they have a forum. You can ask questions there. And usually, if you Google it, you will get most of the answers from this GIS Stack Exchange only. So you can use this as well to like get any answer to your any queries and all. So anyone have any questions? Like,
So there is one question, like I was yesterday sitting with Hariom, and he was asking me like how to get a maximum value of the earthquake
Yes,
in a
sir.
buffer zone. So can it be done like automatically using qGIS?
So it can be done, but I'm not sure which there is a buffer tool. But I was also discussing with Hariom that which tool we can use. But there are a lot of tools in QGIS. There is a tool in ArcGIS that can be used. There is a proximity tool that they can explore if they can use that tool.
Okay.
And I'm not sure about QGIS, but there must be something because there are a lot of functions there.
Mhm.
So there must be something that we need to figure out to automate that task because
So
there are a
like
lot of like tools and
for
all.
because you also did similar kind of study. So for your
Yes.
purposes, how did you perform that task?
So actually, at that time, I was new to QGIS, so we did it manually. But
Oh
after
wow.
that, we thought, yeah, after that, we thought like, okay, we should like try to see if we can automate. So we came around like there is a proximity tool in ArcGIS
Okay.
that can be used, but they can see to it if they can use. But I am not sure about like if there must be something in QGIS, but they need to explore and see like to find something.
Okay. Okay. So is there any question from other people? From master's student, PhD student, any other person? So this
Yes, sir.
the link that you have sent us about ArcGIS and QGIS, it's really available.
Yes, sir. These data are freely available. Like you can go to, like you can download shapefile for country, and these are only some of the links. We have all. There are a lot of websites that offer like freely data. That we have ISRI also. Like ISRI also offer a lot
Mhm.
of free data, but they offer mostly data for different parts of the world. But we don't have a lot of GIS freely available data for India. For India, we can find mostly satellite data using Bhukosh or Bhuvan that is maintained by GSI. We can get satellite data and we can get shapefiles for different parts of the country and geology using Bhukosh or Bhuvan for India. But for other parts of the world, there is a lot of data available freely.
So when you did your interpolation between your data points, so did you compare how the interpolation is varying between different methods?
No, sir. Actually, there are different interpolation techniques. Several like we have weighted residual interpolation, and we also have like nearest neighbor approach. But like in different studies, I have like they usually for spatial data when we are like going for interpolation using some data which is based on latitude and longitude, that is spatial data. So we
Mhm.
usually go for Kirgin interpolation. That is why I only carried out Kirgin interpolation.
Okay, Arish, like if I remember, there was a paper like I am not sure, but I do remember kind of like vaguely, like they did use the nearest neighbor, right? Nearest neighbor
Yes.
can. So did you compare between the techniques, like how different a result you are getting from using the different interpolation techniques?
No, so I didn't use nearest neighbor, but I did use initially the weighted residual technique. So in that residual technique, we need to give the weightage to different points. Like if the point is far away, then we need to assign some weightage, and if the point is close by your region of interest, then we need to give some different weightage. But I didn't use nearest neighbor. It can be used, but usually for
Okay,
special interpolation, we use Kriging interpolation because it gives same weightage to all the points, and so like it's free of bias.
okay. So is there any question from anyone? Hariom, Aman?
Yes, sir.
Yes, Hariom.
Am I audible, sir?
Do you have any query?
Yes, sir. Sir, in the made a map in ArcGIS. In a similar manner, I was trying to make a map in qGIS. So there, while preparing legend for the map, I was trying to edit something in the legend part. So to edit, there you double click on the legend to edit those properties. So there in QGIS also, I will have to double click on the legend to edit the properties, or is there any other method there?
You can go to the layer now. You can just go to this in QGIS. You can go to the you go to the particular layer. Just you can right click on it. Go to the properties. This is the same property panel that you will get if you will double click. In ArcGIS we can go with double clicking also, but in QGIS you can select the layer Okay, sir.
Is there anyone else? So I guess that is all. So it was a very nice presentation, Rashid, and I really want to appreciate you that you yourself came forward to present this topic for the benefit of the students in the lab. I hope, and I have recorded the video, so I have already got the permission from Rashid that the video can be uploaded on YouTube. So the video will be available there always in case you would like to have a look at on it back. So, so that is all. And Rashid, if you
Thank
have
you, sir.
something like this in the future as well, do educate us, and we will always be there to listen to your talks. And whatever talks we will be organizing, it will be there. We will invite you to the
Yes,
podium
sir.
of the audience. Okay.
Sure.
So, so that is all. Thank you so much, Rashid. Thanks all.
Thank you, sir.